Hey, welcome to our channel. I'm Geetanjali, your math coach, and today we are going to learn divisibility rules. In this video, we will learn how we can determine the divisibility of given number by divisors from 2 to 11 without actually dividing the number by using Vedic math methods. Let's learn to check divisibility without dividing. Let's start with divisibility rule for 2. A number is divisible by 2 if its last digit is 0 or even. This rule says that whatever number is given to you, it may be a small number, it may be a bigger number, you don't need to worry about it. What you need to check is just its last digit, that is its units place digit. It should be either 0 or one of the even number, that is one of the numbers 2, 4, 6 or 8. If you find any of these numbers at unit place digit of given number, then the given number will be divisible by 2. Let's take one example. I've taken 2254. Now you have to test whether this number is divisible by 2 or not. So let's take its units place digit. It is 4. It is an even number. So the given number is divisible by 2. Let's take one more example. The number is 40,175. You have to test its divisibility by 2. So we will check only units place digit, and here it is 5, which is not an even number. It is not 0 also. It is an odd number. So the given number is not divisible by 2. Let's move to divisibility by 3. A number is divisible by 3 if the digit sum of its digits is divisible by 3. So here one new term you can see is digit sum. Some of you might be knowing what is digit sum and some of you may not know what is digit sum. So let's see definition of digit sum first. Digit sum of a number is obtained by adding all the digits in the number until we get a single digit. Digit sum is always from 1 to 9 and never 0. For example, if I take a number 7251 say, and I want to find its digit sum. So first I need to take all its digits. Its digits are 7, 2, 5 and 1. Next we add them. When we add them, 7 plus 2 9 plus 5 14 plus 1 15 is equals to 15. But we can add this again as we want digit sum in 1 digits. So again we can repeat the same process. Its digits are 1 and 5. Add them. So digit sum is 6. So digit sum of 7251 is 6. So this way you can find out digit sum of any given number. There is one more method. Anyways, you are going to calculate it mentally. So I'll tell you one shortcut method. Whenever sum reaches to 9, you just drop that number. For example, if I start here, 7 plus 2. 7 plus 2 is becoming 9. So I will drop these numbers. I will not consider them. Then 5 plus 1. What is left is 5 plus 1. So what is left is 5 plus 1. So answer is 6. So in one step only you can get this digit sum. Okay. In the second method, you will drop sum as soon as you reach to 9. So this is the way how we can find digit sum. Now let's move to the divisibility rule for 3. Let's take one example. Here the number is 327. So we have to check its divisibility by 3. So first of all, we'll take digit sum of the numbers 3, 2 and 7. So we add them and our sum is 3 plus 2, 5 plus 7 is equals to 12. This is 2-digit number. We can repeat the process. It is 1 plus 2 is equals to 3. Or the other method which I explained you, it was 2 plus 7 is becoming 9. So we can drop it here only and our digit sum is 3. Any one of these two methods you can follow to find digit sum of any number. So now the digit sum of the number 327 is 3. So to find its divisibility by 3, we divide it by 3. When we divide 3 by 3, it is completely divisible. So the number 327 is also divisible by 3. This is the way how we test divisibility by 3. Let's take one more example. The number is 5372. So we will find its digit sum. 5 plus 3 plus 7 plus 2 gives us 17, and again 1 plus 7 is equals to 8. Or by the other method, 7 plus 2 is becoming 9. Let's drop it. 5 plus 3 is becoming 8. So this way we got digit sum is equals to 8. Now 8 is not divisible by 3. Since the digit sum is not divisible by 3, therefore the number 5372 will not be divisible by 3. So this was the rule for divisibility by 3. Let's move to divisibility rule for 4. A number is divisible by 4 if the number formed by last two digits is divisible by 4. So here whatever number is given to you, you will check its last two digits. You don't need to worry about the length of the number, and two-digit number is easily divisible. I think every one of you can divide two-digit number. So to test divisibility by 4 is also quite simple. For example, the number is 5212 and you have to check whether the given number is divisible by 4 or not. Take last two digit, and it is 1 and 2, which forms number 12. So let's try to divide 12 by 4. So let's divide 12 by 4. 4 3s are 12. So it is completely divisible by 4. There is no remainder. So last two digits, that number is divisible by 4. Therefore, the given number 5212 is divisible by 4. Next example. The number is 39,225. Same method. Last two digit, the number is 25. So 4 6 are 24, and you don't get 25 in the table of 4. It means 25 is not divisible by 4. Therefore, the given number 39,225 is not divisible by 4. Now the divisibility rule for 5. A number is divisible by 5 if its last digit is 0 or 5. It means at the units place you have to check there can be only two digits. If it is 0 or 5, then only the number is divisible by 5. If there is any other digit at units place, the number will not be divisible by 5. For example, 685625 is our number and we have to test its divisibility by 5. So units place digit is 5. So the given number is going to be divisible by 5. Let's take one more example. The number is 403452. What we will do, we will check its units place digit. It is 2 and it's not 0 or 5. Therefore, the given number is not divisible by 5. Divisibility rule for 6. A number is divisible by 6 if it is divisible by 2 and 3 both. It means whenever you have to check divisibility by 6, you need to check divisibility of that number by 2 and 3 both. The number should be divisible by both these numbers. If the number is not divisible by any of these numbers, then the number will not be divisible by 6. But why do we take divisibility by 2 and 3? The reason is, if you factorize 6, you can find its factors are 2 times 3. These two numbers 2 and 3 are co-prime also. Co-prime means their common factor is 1. Whenever you will study divisibility by bigger number, you will find this property that if you can find co-prime factors of any number, you can test divisibility by that number by using its co-prime factors. The same method we are following for 6. So let's see how we can check divisibility by 6. Our example is 336. You have to check whether this number 336 is divisible by 6 or not. So let's take its units place digit. It is 6, which is even number. So the given number, therefore the given number is divisible by 2. It is divisible by 2. Now to check divisibility by 3, we find its digit sum. And you can see 3 plus 6 is becoming 9. So we'll cancel out that and digit sum is 3. Therefore, the given number is divisible by 3 as well. It is divisible by 3 as well. So the number is divisible by both 2 and 3. Therefore, the number 336 will be divisible by 6. Now let's take one more example. The number is 5174. Its units place digit is 4. Therefore, the given number is divisible by 2. Let's find its digit sum. It is divisible by 2. It is divisible by 2. And when we find its digit sum, 5 plus 4 is becoming 9. Let's cancel it. 7 plus 1 is becoming 8. 8 is not divisible by 3. Therefore, the given number 5174 is not divisible by 3. Therefore, the given number will not be divisible by 6, as it should be divisible by both 2 and 3 to get divisible by 6. So this way we can check divisibility by 6. Now let's move to the next number, which is 7. Divisibility rule for 7. If the given number consists of more than 3 digits, follow the following steps. So for 7 there are many rules to check divisibility. Here I am taking a real big number. Therefore I am telling you this method when you have to check divisibility by 7 for a very big number. There are more than one method to check divisibility by 7. Let's see this method first, in which you can check divisibility by 7 for a big number. So I have taken number 88883291. So what we have to do in this method? First step, make two parts of the number. One part will consist of rightmost 3 digits of the number, and the other part will consist of rest of the digits. So here we take rightmost 3 digits, that is 291, and so our two numbers are 88,883 and the other number is 291. In step 2, subtract the smaller number from the bigger number. Here the smaller number is 291, so we will subtract it from the bigger number 88,883. So when we subtract it, we get 88,592. Now it is still a big number. What we should do? Step 3, repeat the steps 1 and 2 until you get 3-digit or smaller number. This is a big number. We can follow same methods, same steps once again. So we separate last 3 digit. It is 592 is the number and other number is 88. Now 88 is smaller. So we will subtract 88 from 592. When you subtract it, you get sum as 504. Now you cannot follow this method further because this is for the number which is of 3 digit or greater than 3 digit. So in the next step, either the answer should be divisible by 7 or it should be 0. The answer is coming 504 and it is not 0. So let's find out whether 504 is divisible by 7 or not. If it is divisible by 7, then the given number will be divisible by 7. So 7 sevens are 49, 1 and 4, 7 twos are 14. So no remainder. So number 504 is divisible by 7. Therefore, the given number 88883291 is also divisible by 7. So this is the method for divisibility by 7. But it is applicable or it is useful only if the number is very big. Now I am taking one more method. The second method is, this method you can apply for any number. It can be a bigger number, it can be a smaller number also. But the thing is, for bigger number, this method becomes very lengthy. But for a smaller number, this is really good and helpful. So let's see this method. So I'm taking the previous number. We had got 504 in the previous example. So let's work with that number here. By using this method, how you can find out divisibility of 504. In previous example, we had done that manually. So let's see steps of this method. First step, separate last digit from the rest part of the number. So last digit is 4 and rest part of the number is 50. So we separate 4 from 50. In the second step, we find double of the last digit. That is 4 times 2 we will find out, and it is getting 8. And in the next step, we subtract this 8 from 50. So we subtract it from 50 and we have got 42 as answer. You can actually here only conclude, if you know table of 7, you can conclude that 42 is divisible by 7. If you don't know table, let's see, we can repeat the process once again. So we will separate last digit once again. So we have separated it. So double of 2 is 4, and when we subtract 4 from 4, we got 0. So if the answer is either 0 or a number which is divisible by 7, then the given number is divisible by 7. And we have already checked that 504 is divisible by 7, and it is true with this method as well. So you can follow either the second method or the first method, or you can combine both the methods to find divisibility by 7. I'll explain you how you can combine these two methods. Actually, I have done that here also. I'll explain you by one example where we can combine both the methods. There's divisibility by 7. An example is the number is 2979588. So we have to check divisibility by 7. So I'm following, as the number is very big, I will follow first method. In the first method, what we did, we had divided number in two parts. First part is this, and other part will consist of last 3 digits. And its second step was we subtract smaller number from the bigger number. Bigger number here is 2979. So from 2979 we subtract 588, and we get 1 here, we get 9 here, we get 3 here, and we get 2 here. So 2391 is our answer, but this is still a big number. So let's follow the same method once again, repeat the step. So last 3 digits are 391, and this is 2. 2 is smaller number, so we will subtract 2 from 391. 391 minus 2 will give you what? It is 9, it is 8, and it is 3. 389. Now either you can check here divisibility by 7, you need to divide it manually, or we can follow the second method after this. In the second method, we separated this digit, so it became 38 was one number, and the other number was 9, and then we take double of it. 9 2s are 18. Now this number we subtract from 38, so we subtract 18 from 38, it is 20, and 20 is not divisible by 7, therefore the given number is not divisible by 7. This way you can check divisibility by 7. I have combined both the methods, and whenever in the next video I'm going to explain you divisibility by prime numbers. That method also you can apply for 7. We will see that in next video. Right now we are moving for the next number, that is divisibility by 8. A number is divisible by 8 if the number formed by last 3 digits is divisible by 8. This method is somewhat similar to divisibility rule for 4. In that we used to divide number formed by last 2 digits. Here we will divide number formed by last 3 digits. So the number is 52,128. So the number formed by last 3 digits is 128. So let's see whether it is divisible by 8 or not. So 128 divided by 8. 8 ones are 8. 4. 8. 8 6 are 48. No remainder. So 128 is divisible by 8. Therefore the given number 128 is also divisible by 8. So this is the method which we follow. Let's take one more example. Now the number is 392250. So the number formed by last 3 digit is 250. Let's try whether it is divisible by 8 or not. So 250 divided by 8. 8 3s are 24. 10. 8 1s are 8. And the remainder 2. Here remainder 2 means it is not divisible by 8. Therefore the given number 392250 is not divisible by 8. There is one more method to check divisibility by 8, but in that method you need to focus on its hundreds place digit. Let's see that method also. I think you must have understood this method. Please be thorough with this method first and then move to the second method for divisibility by 8. The method is to test divisibility by 8, check the hundreds place digit in the number. So whatever number is given to you, for example, this number is 392248. Check its hundreds place digit. So hundreds place digit, it may be even, it may be odd. Like in this case, this hundreds place digit is an even number. Here too is an even. So if it is even, then what you will do? Then check the number formed by last two digits. So once you have checked this is even, then you will check number formed by last two digit. It is 48. Now you will check whether 48 is divisible by 8 or not. So 8 6 are 48. So 48 is divisible by 8. So 48 is divisible by 8. Then you can conclude that the given number 392248 is divisible by 8. So what does this method say? In this method, you check its hundreds place digit. If it is an even number, you take last two digit of the number and that two digit number you divide by 8. If that is divisible by 8, then the given number is divisible by 8. Now suppose this hundreds place digit is not even, it is an odd number. Then the method is a little bit different. Here the hundreds place digit is 3, which is an odd number. So in this case, what we are going to do, now we will take last two digit, but we will not divide it by 8. We will add 4 to this last two digit. So the last two digits are 28. So we will add 4 to it and we have got 32. Now we will divide 32 by 8, not 28. We will divide 32 by 8. If this 32 is divisible by 8, then you can conclude that the given number 463328 is divisible by 8. 32 is divisible by 8. 8 4s are 32. Therefore, you can conclude that the given number is divisible by 8. So what you have to do is, first of all, you have to be very careful in this method. You will check its hundreds place digit, whether it is even or odd. If it is even, take last two digits and divide by 8. If that is divisible by 8, then the number is divisible by 8. If it is not an even number, hundreds place digit is not an even number, it is an odd number, you will take last two digit, but now you don't divide it by 8. You add 4 to it and then divide by 8. And if the sum is divisible by 8, then the given number is also divisible by 8. So be careful while following this method. At one place you have to add 4, at one place you don't have to add 4. So be careful. Now the divisibility rule for 9. A number is divisible by 9 if digit sum of its digits is 9. We have already checked what is digit sum, and the process, or you can say divisibility rule of 9 is similar to divisibility rule of 3. Only the difference is now the digit sum should be divisible by 9, and I can tell you digit sum 9 is the only number which is divisible by 9. So let's check the number 891. I told you wherever there is 9 you just cancel it. So the digit sum is 8 plus 1 9. So the digit sum of the given number is divisible by 9. Therefore the given number 891 is also divisible by 9. Let's take one more example. The number is 5374. Let's add and find its digit sum. 5 and 4 can get cancelled. Sum is getting 9. 7 plus 3 is 10. 1 plus 0 is again going to become 1. 1 is not divisible by 9. As the digit sum is not divisible by 9, so the number is also not divisible by 9. Now very simple divisibility rule for 10. A number is divisible by 10 if its last digit is 0. Very simple, you have to check last digit. If it is not 0, it is not divisible by 10. So the number is 68970. You can see units place digit is 0. So the given number is also divisible by 10. Next example, 40312 units place digit. It is not 0, so the given number will not be divisible by 10. Now the divisibility rule for 11. A number is divisible by 11 if the difference between the sum of digits at even places and sum of digits at odd places is either 0 or divisible by 11. So first thing what you need to do is, whenever a number is there, you have to segregate its even place digits and odd place digits. For example, the number is 961631. You have to check its divisibility by 11. So first you segregate its even place digits and odd place digits. Now add them. So sum of 9 plus 1, 10 plus 3 is 13. And sum of 6 plus 6, 12 plus 1 is 13. 13 minus 13 is going to be 0. As we have seen that the difference should be either 0 or multiple of 11. So it is 0. So the given number 961631 is also divisible by 11. Let's take one more example. The number is 865472. So what you will do, first segregate even place and odd place digits. Add them separately. So at 8 plus 5 plus 7 is going to become 20, and 6 plus 4, 10 plus 2 is 12. So 20 minus 12 is 8. It is neither 0 nor a multiple of 11. So the given number will not be divisible by 11. There is one more method. It is shorter than this method. Let's see the other method also. It is quite exciting method also. Let's see that method. In this method, you need to follow a few steps to check divisibility by 11. I'll explain you with the help of example. The number is really big and you have to test its divisibility by 11. So in the step 1, we form pairs of 2-digit numbers starting from the rightmost number. It means you need to find pair of 2-digit numbers starting from here. So first pair will be this, second pair will be this, third pair will be this, and fourth pair will be this. So we have formed pairs. So our pairs are 62, 10, 26 and 78. And now what's the second step? In each pair, find difference of 2-digit number from multiple of 11. It may be positive or negative. It means we need to take close multiple of 11 for each pair. For here the number is 78. So close multiple of 11 close to 78 is 77. And 78 is 1 more than 77. So the difference is 1. Same with this pair. Close multiple of 11 is 22. And this is 4 more than 22. So the difference is 4. And now the close multiple of 11 is 11 for 10. And it is 10 is 1 less than 11. So the difference is minus 1. Now the close multiple of 11 to 62 is 66. And 62 is 4 less than 66. So the difference is negative. In the next step, we add all these differences. Means we will add all these numbers along with their sign. It means if it is negative, it is positive, it will get cancelled. It is negative, it is positive, it will get cancelled. So we have added and we found the sum is coming 0. So if the result is 0 or multiple of 11, if the sum of these differences is either 0 or 11, then the given number is divisible by 11. Here our sum is coming 0. So the given number 62102678 is also divisible by 11. Let's take one more example so that you understand this method properly. And our next example is 72785. This is the number. So we follow the steps. First step, we make pairs starting from rightmost. And our pairs are 85, 27. We don't have got any pair for this. We'll keep it as it is. So our pairs are 85, 27 and 7. In the next step, we take difference from the close multiple of 11. So for this pair, close multiple is 88. And the difference is minus 3. And for this pair, the close multiple is 22. 27 is 5 more than 22, so difference is plus 5. And for 7, the close multiple is 11. So difference from 11 and 7 is 4, and 7 is 4 less than 11, so it is minus 4. In the next step, we add all these numbers. So minus 4 plus 5 minus 3. That will give you minus 2. So as the sum is not divisible by 11, so the given number will not be divisible by 11. So that's all about the divisibility rule till 11. But you must be thinking, why divisibility rule? Well, divisibility rules help us to build number sense and not to be afraid of large numbers. Sometimes in many competitive exams, questions are tricky, and at the same time, you're required to be really fast in calculations. That time, divisibility rules are of great help. I'm presenting you one example here, and I'm going to make separate video for questions based on divisibility rules. The question says which number should be written in place of x in the number x72785 so that the number becomes divisible by 11. So right now it is a 5-digit number. You have to place something in place of x, and it is going to become a 6-digit number. You have to find that digit which you should put here. So I'm going to follow the second method for divisibility rule by 11. So it is we have found pairs of the numbers starting from rightmost, and our pairs are 85, 27 and 7. And the second step is we find difference from close multiple of 11. So close multiple of 11 is 88. Here it is 22. I'll look at this later. So here if I find difference, it is 3 less than 88 and it is 5 more than 22. Now if I add them, I get plus 2. And as per our rule, if the sum of the differences is either 0 or multiple of 11, then it is divisible by 11. So I want to put something here so that this difference comes minus 2. If this difference comes minus 2, this will get cancelled with this and our sum will be 0. So out of the given option, if I put 9 here, the number becomes 97 and close multiple of 11 is 99. So the difference is going to be minus 2, and if I write minus 2 plus 2, it is going to get cancelled and your answer is 0. So the sum of the difference is coming 0. Therefore, the number 972785 will be divisible by 11. Therefore, the digit which you will place in place of x will be 9. I took this much time because I wanted to explain you. When you understand method, when you practice it thoroughly, you can solve this question within seconds. So that's all for today. Now the summary. I haven't written detailed steps of summary because we have already done while practicing it. I have just categorized these numbers according to some properties. For example, 2, 5 and 10. To check divisibility by these numbers, you just need to check last digit of the given number. And for 3 and 9, you need to find digit sum of the given numbers. And for 4 and 8, either you check last 2 digit or last 3 digits. And for 6, you need to find relatively prime factors and then try to find divisibility by those factors. And for 7, there is a divisibility rule by prime numbers. I haven't explained you here. I have explained you 2 different methods to find divisibility by 7. If you have any queries or ideas that you would like us to present, please leave the comment below. Check out our other videos as well. Thank you so much for watching, and if you like it, please don't forget to subscribe.